Okay, now we'll be talking about alkane part 2, in which we'll be discussing about its reactivity, then how reactive it is. So reactivity cannot be discussed without the strength of the bond. And strength of the bond of what? Of carbon and hydrogen and carbon-carbon. One thing you need to know that both of them had what? Both of them covalent bonds. And they are very strong covalent bonds, like literally very, very strong covalent bonds that a lot of heat is supplied to break the bond between carbon and hydrogen. Since a lot of heat is required, a lot of energy is required to break the bond, that is why the reactivity of alkane decreases. Okay, so what did we say? We said that the reactivity of the alkanes decreases, and why the reactivity of the alkane decreases? Because it needs a lot of energy. The other thing which you need to know about the reactivity, or when we are talking about the reactivity of anything, is the polarity. Either the atom is polar or molecule is polar or non-polar. Now, what is the difference between being polar and being non-polar? See, if we say polar, what do we mean by that? We mean that there are two elements connected together in which it has partial positive and partial negative charge. And when we say non-polar, now what do we mean by that? That there are two elements which are connected to each other, electrons are equally shared between them. Okay, so as far as the polarity of covalent bonds are concerned and hydrocarbons, which we are talking about, basically the thing is that electronegativities, and what electronegativities are we talking about? We are talking about the electronegativities of the carbon and hydrogen atom, all right? Carbon and hydrogen atom in alkanes are almost same. Alkanes are almost same. Since the electronegativities are almost same, so what does it mean? It means that the electron between carbon and hydrogen is shared equally. So when the electron is shared equally, there is no polarity. And when we say that the atom, or when we say that the compound or the molecule is non-polar, it has no partial, it has no negative, a partial negative or partial positive charge. That means they do not react with polar reagents. What do we say? We say that they do not react with polar reagents. Now, what are polar reagents? Polar reagents are the one which have partial positive charge and partial negative charge. Why is that? It is because they have no electron deficient areas. They have no electron deficient areas to attract any nucleophile, or they have no electron deficient areas to attract nucleophiles. Or we can say that they have also electron rich areas, and these electron rich areas are to attract what? To attract electrophiles. I repeat it again. What do we say? We said that we are talking about what? We are talking about polarity. And when we say polarity, in polarity, we have two kind of categories. What two kind of categories are there? Either they are non-polar or they are polar. When we say polar, polar means that they have no partial positive or partial negative charge. See, when the charge comes when an atom is giving an electron. Either it is half giving or it is full giving. If it's half giving, that means a partial positive charge. If it's half accepting, that's a partial negative charge. Sorry, that is in the case when it's polar. It can be partial positive or it can be partial negative. When it's non-polar, means electron is shared right at the center. When we're discussing about what? When we're discussing about the carbon-carbon, or when we are discussing, they are the similar. When they are similar means they have same electronegativity, they have same power, the electrons are shared right at the center. And when we are talking about carbon and hydrogen, even in this case, the electronegativity difference is much less. When the electronegativity difference is much less, that means it makes it non-polar. And when it becomes non-polar, that means it do not react. Do not react with what? Do not react with polar reagents. All right. It does not react with polar reagents. Now, there are two things. What two things are? Number one, that they have no electron deficient area. No electron deficient area. When it has no electron deficient area, so of course, nucleophiles will not be attracted. Now, what nucleophiles are? Nucleophiles, all those ions which have negative charges. Like, for example, OH is a nucleophile because it has a negative charge. Chloride is a nucleophile because it's a negative charge. Iodide is a nucleophile because it has a negative charge. And then lack of electron-rich areas. When we say lack of electron-rich areas, that is to attract what? To attract electrophiles. Now, what are electrophiles? Electrophiles are the ones which have positive charge. So if there is electron rich area, it will going to attract a positive one because opposite charges attract each other. If it's an electron deficient area, that means it has a positive charge and that will going to attract what? That will going to attract a negative charge. So because they are unreactive, generally alkanes are unreactive. The only reactions that are possible in them are either it is combustion, or the other reaction that is possible, it is substitution. We have already discussed about combustion, but let's just, for the sake of discussion, let's discuss it again. Now, what combustion reactions are? See, combustion reaction are those reactions in which any hydrocarbon, all right, it can be an organic compound also. We can talk about others as well. Any hydrocarbon, but right now we're talking about hydrocarbons, so I'll be talking about hydrocarbon as well. Any hydrocarbon, when it is reacting with oxygen, it is changing into what? It is changing into carbon dioxide and water. For example, let's suppose if I take C2H6, right? If it is reacting with oxygen, it is producing what? Carbon dioxide plus water. What kind of reactions or what kind of equation comes in? The equation that comes in related to this are to balance, basically. For example, here if I say at that side right now, carbons are 2. Here if I see the carbon is 1. Here if I see hydrogen is 6. And here if I see hydrogen is 2. Here if I see oxygen is 2. And here if I see oxygen is 2 plus 1, 3. Now, here's the trick. The trick is first you're supposed to balance the carbon. If you balance the carbon, then it will be easy for you to balance the other things as well. Now, let's suppose here carbon is 2. I can't put any number over here. I cannot. So I'll put a 2 over here. Now, the carbon is balanced as 2. As far as the hydrogen is concerned, there are 6 hydrogens, and here there are 2 hydrogens. I put a 3 over here. Now, when I put a 3 over here, this makes it 3 multiplied by 2, that is 6 hydrogens now. Carbons are balanced, hydrogens are balanced. What we are left with are oxygen. Now, oxygen is 2 over here. However, here, now 3 oxygens. This 3 is with this hydrogen and this 3 is with this oxygen as well. And since it's 1, so 3 times 1 will be 3. Plus 2 twos are 4. So 4 plus 3 oxygen, 4, 5, 6, 7. So how many oxygens over here? 7 oxygens. So what we do is we put a 7 upon 2. Now what happens is if I say 7 upon 2 is to 2, so we are left with how many oxygens? 7 oxygens. So 7 upon 2 over here. Now this equation is balanced, and that's how this question comes in, is to balance the equations. I hope it makes sense. You can always do balancing of equations over and over again to practice. When it comes to combustion of what? When it comes to the combustion of alkanes, it affects what? It affects environment. All right. So, and how does it affect environment? That's really important. How the combustion is going to affect environment. For example, number 1, cars exhaust fumes. They include what? They include toxic gases, And what toxic gases we are talking about? We are talking about carbon monoxide. We are talking about oxides of nitrogen, nitrogen monoxide, nitrogen dioxide. And we are talking about what? We are talking about volatile organic compounds. And what do we say about volatile organic compounds, VOCs in short? When they release in atmosphere, they cause damage to the atmosphere. Carbon monoxide, it is now how the how these hydrocarbons attach with it. So when I talk about when I talk about carbon monoxide, how does this carbon monoxide produces? This carbon monoxide is basically produced with what? It produced with incomplete combustion of alkenes in car engines, and it is very toxic. So if I have to remove it, if I had to make it more harmless, how can I do it? I can do oxidation. Oxidation of carbon monoxide with oxygen, it can change into carbon dioxide. I won't say carbon dioxide is not dangerous. However, yes, it is less dangerous than carbon monoxide. Or it can be reacted with nitrogen monoxide and can be changed into carbon dioxide and nitrogen gas. So this happens where? This happens in catalytic converter. I hope it makes sense. Now, there's another thing, which is what? Which is VOCs, volatile hydrocarbons and unburned. Basically, what are these? These are unburned hydrocarbons from fuels, and they are oxides formed in car engines. And what do they do? In the next, they react. They react with what? They react with oxides. And when they react with oxides, they react with oxides of nitrogen, produces PAN. Now, what this PAN is? PAN is basically it's a pollutant. It's a photochemical smoke. What is PAN? PAN is a photochemical smoke. So the unburned hydrocarbons, which are very volatile, if they react with the oxides of nitrogen, what they produce PAN, which is a photochemical smog. And what it is very harmful. And harmful to what? It is harmful to lungs, it is harmful to eyes and plant life. So that's how the hydrocarbons, they are affecting our atmosphere. The last part is the free radical substitution reaction. This is the only kind of reaction that, other than combustion, what it's being done by alkane, free radical substitution reaction. Right. Now, free radical means, of course, a free radical is produced. A free radical is produced with the help of an energy. Since they are very unreactive, so this to produce this free radical, we need a very maximum amount of energy, and that energy is UV light. The source of energy which are using in this are UV light, and it happens in steps. So the first step is initiation step. Right now, what this initiation step is, here basically either it can be chlorine or chlorine, or either it can be bromine or bromine. So this reaction, halogens are involved. These halogens are replacing the hydrogens. So they will be broken. They will be broken. Either this, either this. They both will be broken by UV light. That's the main thing. That will be broken with UV light. And what happens? Homolytic fission. Now, here's the concept. See, when two elements are breaking down, either it can be homolytic fission or either it can be heterolytic fission, right? Now, what is the meaning of homolytic fission? Homolytic fission means, for example, if chlorine and chlorine are breaking down, they, when they are in molecule, they are sharing electron. The electron is shared. So after breaking, this chlorine is taking its electron and becoming a free radical. And why it's a radical now? Because it's highly energized. It has absorbed energy, so it is highly energized. And this chlorine is taking its own electron. This is also a radical because it is highly energized. Well, if heterolytic fission is happening, which is not happening in this case, but I'm just telling you the example, when electron is being shared, so one chlorine will lose electron and get the positive charge, and the other chlorine will get the electron and get a negative charge. It's just an example to understand that in heterolytic fission, when the molecule is broken down, the molecule is broken down as a positive ion and a negative ion. In a homolytic fission, when the molecule is broken down, it is broken down as two free radicals with have their own electrons, but a good amount of energy. So in alkanes, what happens in the initiation step? We give UV light. In the result of UV light, homolytic fission happens. And when homolytic fission happens, what happens is this chlorine and chlorine in the presence of UV light will be broken down and produce two chlorine radicals. This is the same case, or this is the same case with bromine can be in the presence of the UV light, two bromine radicals can be produced. Okay, the next step is, let me see. So the next step is propagation. Now, what happens in the propagation step? In propagation, the free radical that was produced in the initiation step, it will going to attack hydrocarbon. Let's suppose that hydrocarbon is ethane. C2H6, I have broken down like this. Now, what will happen? Homolytic fission will going to happen. All right. Homolytic fission of going to happen of carbon and hydrogen bond. And that homolytic fission, what happens is one hydrogen will be removed from here. When one hydrogen will be removed from here, it will absorb the energy of Cl. It will absorb the energy of Cl and it will become itself a free radical. It will lose a hydrogen, absorb the energy and become a free radical itself. And the hydrogen that will go on from here, it will combine with Cl and form hydrogen chloride. Now this is again a radical. And what kind of radical it is? It is alkyl radical. Now what happens? This alkyl radical, we're going to attack another molecule. Maybe this. So here, now it will break the chlorine. It will take one chlorine. So one chlorine will going to come and attached over here, and one chlorine will become a free radical once again, ready to attack another one. The cycle goes on and on. Now this is what we call chloroethene. So this will attack again, and the first step will going to be repeated, and the reaction will go on and on and on and on and on till termination happens. All right, that will be the last step. Then what is termination? Let's suppose termination is when it ends, when it stops. And how is that possible? When as a result, no free radical is being produced. For example, there were two free radicals, CH2, CH3. They react with Cl and form what? Cl, CH2, and CH3, and form what? Chloroethane. Or maybe a possibility that CH2, CH3 plus CH2, CH3, they form what? They form CH3, CH2, CH2, and CH3, which is C4H10. And what this product is butane. No free radical is being produced. Or maybe a possibility two chlorines are reacting together as free radical and producing what? Cl2. Reaction stop or terminates when no free radical produces. I hope it does make sense. And with this, the end of Alkalene. See you in the next video.